Right, I'll show you how to answer some questions on magnetism and the motor effect. Now this is just a short chapter, there's only 17 questions, or rather 17 marks worth of questions from the last 4 years or so. Right, question 1. A student has a power pack, a long piece of wire, a stiff card, and some iron filings. Describe how the student could use this equipment to show the shape of the magnetic field produced by a current in the wire. You may draw a diagram to help with your answer. Right, so if you got a piece of card and you put iron filings on, they would just be all over the place like that. However, if you took the card and you put a wire through, now they're saying a power pack, so we'll use DC power pack. If they said a battery, obviously you'd put your battery there like that. Right, now those iron filings, if we put a current going through, so a current coming upwards like that, the little iron filings will all start to go in circles like that. So that's before you turn the current on, and that's after. Now, you'll probably get the marks for that because it said you are allowed to draw a diagram, but if you want us to write it out for you, this is how I would see it. Number 1. Put a wire through the piece of card. Number 2, turn on the circuit or turn on the current. Number 3, the iron filings would be attracted to the magnetic field. And I'm going to use their words, magnetic field produced by the current in the wire. Iron filings would be attracted to the magnetic field produced by the current in the wire. So use their question as the framework for your answer. Right, you'll get 4 marks for that. Question 2. Figure 5 shows 2 magnetic poles facing each other. The magnetic field between the poles is uniform. So uniform means it's all the same, just like if you're wearing a uniform at school. On figure 5, draw the magnetic field lines between the 2 poles and show the direction of this magnetic field. Right, it's always the same. What you want to do is draw at least 3 straight lines. Make them equal distance apart from each other. So you'll get 1 mark for putting those lines on, and you'll get another mark for knowing that the magnetic field travels from North Pole to South Pole. So just to clarify, for 3 marks, you'll get 1 mark for drawing any straight line. You'll get your second mark if you've drawn more than 1 straight line, so draw 3 lines equal distance apart. And your third mark will be for the arrow going from north to south. Okay, so if you literally just draw that picture there, that'll get you the 3 marks. Easy. It's a type of question where once you know how to do it, it's easy. The same as the first question was. Question 3. Answer the question by putting a cross in the box. Right, which of these is a magnetic material? Right, well, I use zinc to help us remember. So zinc to think. Right, so you've got steel, iron, nickel and cobalt, and they are the 4 magnetic materials that you need to know about for GCSE. So there you go, cobalt. Steel, iron, nickel, cobalt. Question 4. Figure 4 shows the magnetic field produced by a current in a long straight wire. So this is similar to question 1. They've got the current in the wire going upwards and the magnetic field going around. Which row of the table is correct when the strength of the magnetic field is greatest? Right, so if you want the magnetic field to be the greatest, you need to be close to the wire. So you want the distance to the wire to be small. So it's either that one or that one. And you want the current to be large. So the answer is B. Question 5. Figure 5 shows a magnet holding some paper clips. Describe how a student could show that the paper clips are induced magnets. Now, induced just means temporary. Right, all you've got to do is basically disconnect that magnet from the paper clips. They'll no longer be magnetic and they'll all drop apart from each other. The paper clips will drop away from each other. Question 6. Describe how you could show that the Earth has a magnetic field. 2 marks. This is one of those questions where I've seen students waffle on for ages. Watch this. Use a compass. It will point north. Bang, done. That's why it's important to practice. You can make the exams really easy. Once you've practiced them, you see the question come up and you think, oh, this is so easy to answer. If you don't practice, you could very well struggle. So practice is the key. Question 7. Which of these materials would be the most suitable for making a temporary magnet? Well, remember, zinc, steel, iron, nickel and cobalt. I think I spelled nickel wrong before. Right, the problem is both iron and steel are there, so it's either going to be B or D. Now the difference, they're just wanting a temporary magnet. Right, the way I think about this, and I teach my students, is iron is not as hard as steel. If you magnetise steel, it's going to stay permanently magnetic. Right, iron will only stay a magnet temporarily. So that's what we want. And that's because iron is softer than steel. Question 8. A student uses a compass to investigate the magnetic field near a bar magnet. The student places the compass near the bar magnet as shown in figure 6. Part 1. Mark the north pole of the bar magnet with an N in figure 6. Right, the magnetic field always travels from the north and goes into the south. So it comes out of the north, goes into the south. Right, well that arrow's coming out. So that must be north. And what will happen is that would come all the way around here like this, and it would go in to the south like that. So that's probably going to be part 2. Part 2. State 2 ways in which the investigation could be developed to show the shape of the magnetic field around the bar magnet. You may add to figure 6 to help with your answer. Right. What you do, you'd draw a little arrow the way that this compass is pointing. Then you'd take the compass and move it to the tip of that arrow. And then what would happen is the compass would be pointing like that. So then you draw a little arrow pointing the same way as the compass. Then you would move your compass there. And then whichever way the compass is pointing, you then draw another little arrow. And if you keep on doing that, what you'll find is that the compass would come round like that. and you'd end up getting the shape that would show you the shape of the magnetic field. Now, I might not have done that perfectly there. Should have came down here a little bit more. Now, how do I write that down? Draw an arrow which way the compass is pointing. Move the compass to the end of the arrow. Repeat this process until you get to the South Pole. Of the magnet. Join up the arrows. So you'd end up with that there like that. Put your little arrows on to show which way the direction's going. Now, instead of drawing arrows, you could say put dots and then keep moving the compass to where the dot is. But I like to do the arrows because then not only does it show the shape, but it also shows the direction as well. An alternative way of doing it would be to say to sprinkle iron filings all over the place, and they would sort of line up with the direction of the magnetic field, and that would be on both sides. Now, they did say you could develop it, so, you could say to use iron filings, but I always find it safer just to use what they've given us, rather than start using new things, if you know what I mean. So you might think it's a lot easier to remember. So it's up to you whether you take the risk. Just if they've got the word develop there, that probably means you can use what you want. Right. Well, as I said, that's just a short chapter there. So it's important still to practice. Remember, every time you get an extra 6 marks, you jump up a level. How do you get to 100%? 1 mark at a time. So you want every mark you can get. Work hard, be nice, and bye for now.